right, greetings everyone, and welcome to another great episode of IT Pro TV. I'm your host, Daniel Lowry, and in today's episode, well, we are finishing up our Programming with Python series. Hopefully you guys have enjoyed it so far. Joining us back in the studio again today is our good friend and mentor when it comes to Python, Mr. Justin Dennison. Justin, welcome back, sir.
Thanks for having me. We're finally at a point to where we can kind of put all of these tools that we've been accumulating over the last few shows and put them to work. Like, how would we actually use these in the context of, looking at server logs or looking at process logs, or even just doing some maybe nice little science projects like what's called a frequency analysis, where I can do character counts of something that's encrypted, and if it's not real secure, I can make pretty good guesses and do a find and replace and break a lot of encryption algorithms. Not something like RSA or anything like that, but like Caesar ciphers or shift ciphers or things like that. But before we get into that, let me kind of set the scene. Here's what I've done. Finding server files, server logs, that's kind of weird, and maybe you know something about those, or maybe you don't. So I've tried to take an approach of, I'm going to pretend that these text files are server logs when in fact they are stories. I've went to Project Gutenberg, which, if you don't know, is a way to grab out of copyright, or kind of like public domain. Yeah, public domain stories. And how do we sift through these? And these are hundreds of pages long, and they're just simple text files. So I went to Project Gutenberg, got those, I have those up, and now I'm going to start sifting through those and just looking for keywords like I would in a server file, or in a in a log file. So let's see how this all works together. So first off, I'm going to make my let's just make it call it searcher.py, sudo chmod plus x. I definitely did not spell that correctly, so we're going to fix that. So I'm going to move that to searcher.py, and so I think we're actually good to go to hop over into Atom and see all of these things, how we can use these. So I have Bram Stoker's Dracula, I have Frankenstein by Mary Shelley, and then I have Sherlock Holmes by Sir Arthur Conan Doyle. So some great stories, but I really, everybody, my push for this was, everybody was like, it's not actually Frankenstein, it's Frankenstein's monster. So I was like, I wonder the story, how many times is the word monster used in Frankenstein? I don't know. Let's find out. So I'm going to add my shebang here and say user local bin and Python, and that's my Python interpreter. That's the one that's currently running on my computer. Yours may be in a different place. If you're on StarNext systems, just type which Python in a terminal, and it'll give you a path to that. And now this is executable. So set up my main chunk here. And this just runs as an executable. Other stuff would run, but I like to have this because I can use functions and not have to worry about, what's actually running when I run the file? Well, if I run from the terminal, I know the main sections, what's running. The function definitions are just there for convenience for me. So let's start with Frankenstein. I'm going to start just with one file and kind of build this up, and this emulates how you would go about programming something of a large complexity. And I find that when people start, they get really overwhelmed. Oh, look, I don't know all these things that are going on. And that's typically not how anybody starts programming. You take it little bite size, you iterate through these just like you would in normal programming. So let's open. So with open, and I'm inside of this directory. So I'm going to open and just read in. So with open as F, we saw that that's a context manager. I can read those in, so I can say Frankenstein text, and just say f.read, and I'm going to read in all of those, because I'm just going to run through each word, and actually I'm going to go ahead and say Frankenstein text is going to be equal to Frankenstein text. Wow, I should maybe pick a better variable name, just as easier to say. And I'm going to split that just on spaces. So I'm going to get every word in there as a list of elements. But just to make sure, let's go ahead and run this. Print, and I'm just going to say print Frankenstein text, and I'm going to print the first 100 elements, just so it doesn't go bleh on the screen, so I can kind of make heads or tails of it. So there we go, and it looks like I do, in fact, I have some weird Unicode characters here. I don't care about that, but I have individual words kind of pieced out, and now I can iterate through those. So, okay, I have that, and I can start here and just say for word in Frankenstein text, if word equals monster, then print, let's just say there, right? Okay. So let's go run that, and it looks like I could count those and figure out how many times the word monster is used in Frankenstein, and that was fast, right? I had an idea, and in, 9 lines of code, I have a working prototype. One of the best things about Python, I can tell you I have some Java experience. Man, I actually almost had a horrible flashback just now thinking about reading in files in Java. But I think we can make this better. I now have a better idea. Let's see how many times, so we can compare, Frankenstein, the word, and monster, the word, were in this text. And let's actually keep a count. So, okay, I need to go back and change some things and say word count. And I'm just going to make a dictionary and say, okay, Frankenstein. And I know that's a name, so I'm going to say capital F. And I'm going to set that to 0. And I'm going to say monster and set that to 0 as well. So now I'm looking for these words. But I actually need a list of words that I'm looking for so I can see, and am I looking at what this is? So search words. And this is going to be a little duplicated, but that's okay. I think it's easier to reason about when we do this. So then monster. And now I'm going to change this a little bit. I still want the text. I want to read it in. I want to split it into words. And then I want to go through here, but I want to change this part. If word in search words, then I want to say word count of the word, and I want to increment it by 1. So every time I come across that word, I want to increment it by 1, and I want to print word count. Frankenstein occurs 8 times, monsters occurs 18 times in there.
So a much nicer output format just by adding a little bit of extra code, giving it some formatting.
Exactly. So, you know, Daniel, I'm going to pick on you a little. What are some other words that you think might come up regularly? I mean, they can be words related to the story or just words that you're like, oh, I wonder if that's in there.
Okay, well, let's go with, how about the word afraid?
Okay, afraid. And I'm going to add another one in there, the. Right, that's a
very
common word that we use in English. And I'm just going to start that there, and then I'm going to add it to my list here. So afraid and the. Okay, so I have my search words, and actually just by changing that, I now have a new version that I can go through and look very quickly. Hey, Frankenstein's 8 times, the is 3,409 times, afraid is 1 time. Isn't that kind of surprising in the Frankenstein text?
Yes, especially since it's kind of a horror, a lot of dark theme is going on. You'd think there would be more people afraid, but apparently not. It's a very sunny, good place to live, Frankenstein's monster.
Right, so I could do a word analysis on this, and sometimes you find surprising things, but Frankenstein could be easily replaced by the word error, or
Right.
something of that nature, or log, or something like that, where you know how these are going to be formatted. And I'm going to do you one even better. When this runs, instead of printing it out, because this is still not the greatest, how about we say we create a new file that is a CSV, outputs it so we can open it inside of like a spreadsheet utility.
Awesome.
So let's do that, and I'm actually going to write a function that just prints out word count. So print CSV, and it takes a dictionary of word count. So, okay, I know what this is, or better yet, this would probably make CSV. That's probably a better term. Now, I'm not assigning a variable, I'm just passing off this functionality. It makes it a little more readable to me when I have it like this. So, make CSV, and this is going to be a word count dictionary. So it's going to look just like this, and so with open, and maybe I should tell it how to save this. So I look at this and I go, okay, maybe I need a file name. And then Frankenstein analysis .csv. Okay, so a comma separated file. I'm like, okay, I'm going to start with word count. Oh, it's probably easier to have file name. So when I open this file name as a writer, as F, right? I'm just going to say F. For the key value in word count.items, I'm going to f.write, and maybe we should put this in a variable. So this would be a row, comma, and then a new line. So this would be the first element, so the first column, a comma, the next column, and then go to the next line. And then key value. And notice I've tried to make this as general as possible because I know it's a dictionary of key values that I want in comma separated value or comma separated form, and I know I can give it a file name. Cool. Well, let's see if it works. That's the real proof there. Does it work?
Write code all day long and get a whole lot of nothing back, right? The
Yep.
whole point is I want this thing to do what I think it should do.
Yep. So, what do we got here? There's my file. Did I? Wait a minute. Oh, I forgot something. I forgot to actually write the file. So I want to write every row that I create. So,
Great debugging skills there. Just
yep, there's your problem. There's your problem. And I actually do have comma separated values. And I think what's really powerful is, can I open this in a spreadsheet utility?
Yeah, that would be cool.
Well, it just so happens that I have a spreadsheet utility. Let's open file, and let's see here. Where do I have this? So learning Python, this is putting it all together, and Frankenstein analysis, and is it going to work? Where is CSV? There we go. So I open it, and I, in fact, it's not going to let me zoom in here as easily. View, zoom, 150. So as you'll see, I actually have a file that I can open in a spreadsheet, and now I can use all of my spreadsheet understanding to further analyze these. I've used Python to create information that I can then manipulate.
This is very, very cool stuff. This is the meat and potatoes, why we wanted to do a Python course, to show you exactly how flexible this language actually is and how powerful it is as well. Now Justin's outputted the necessary information into a CSV file. Now anybody can start an analysis on that. He can email that to someone and say, hey, here's our statistic, guys. You need to take a look at that and see what's going on with this this Frankenstein book. We've got a lot of different types of words being used there, or whatever the case may be. Of course, we're having a good time with it and kind of having fun. But this could have easily been a log file. And if I'm just looking for errors, or I'm looking for a specific error, maybe I'm looking for authorization errors, right? Or I'm looking for system errors itself. This is going to give me that flexibility to write my own program to output that out to a CSV. So all I got to do is open up my favorite type of spreadsheet program. Maybe it's Excel, maybe it's LibreOffice, whatever the case may be. Throw it in there, take a look, and get only the pertinent information that's necessary for me, because goodness knows that we spend plenty enough time pouring through logs and application files and all that other stuff, looking for the pertinent data. And yes, again, we've talked about it before, there is third-party systems that will do that, but you're confined to those systems themselves. Wouldn't it be nice for you to be able to create your own customized script that does exactly what you need, only gives you the outputs you're looking for, and if you ever need to make a change, well, you can jump right back in there, create the function necessary, and make that change, get the output you're looking for. Justin, very cool so far. Anything else that we have to take a look at?
Oh, we're not done yet.
But wait, there's more.
But wait, there's more.
You act now.
So what's amazing is we have this general look here. I'm going to do something that's called a refactor. I'm like, okay, I don't want to open just Frankenstein.txt. I want to open all of the files that I have in this particular folder. Well, we have OS tools. We can make a function that takes all of these requirements, right, and then would just spit back a dictionary with this information. And I could just iterate through all that and get a nice little tidy package and make multiple files. Ooh, handy dandy.
I
So,
believe it can be done, sir.
well, it might not be, but we will definitely give it a try. So I'm going to say, let's just say get file info, and it's going to take the file name, and it's going to take the search words. And notice that I can use the same variables here in this parameter that I can in my main method, because these are these are disjoint. One is global, one is functionally scoped. So what do I do? Well, I want to do this part, so I'm just going to grab this, cut it, and I may have to make some changes, paste it, and then this is just going to be text. So I'm going to change Frankenstein text to just text, because now we're generalizing this, and instead of opening Frankenstein.txt, I'm going to actually tell it what to open as a parameter to the function. And search words is, well, I'm still using that already, so this is a pretty good refactor, and we need to make sure it works. We have a commonly, an already existing setup that we know exactly what it should give me, and I'm going to delete this Frankenstein analysis just to see if it does work. Move to trash. So I'm going to come over here, and the one thing that it's not going to work right now, it's not going to give me this output, right? We have to change this a little bit. So for word in text, if word in search words, word count, there's one thing that we have to do. I need to create a result which is like word count, and I'm just going to make an empty dictionary. And if word in search words, I need one final qualifying statement. If word in result, then result of word plus equals 1. So if it's already there, increment its count by 1. Otherwise, Uh-oh, you about let me mess up there, Daniel. Apparently, I have lost the ability to type. Otherwise, create a new entry and set it equal to 1. So now this is general. I can give it whatever list of words I'm looking for. And I've now created a new tool for my toolbox. Hey, I can just give it a list of words in the file name, and it'll give me an output of how many times those words appear, regardless of the file or the list of words. And then finally, at the very end, I want to return the result. So I don't even need this anymore. Whoa, careful. So I want to say word count is equal to get file info for Frankenstein.txt, and I'm going to give it search words as the list of words. So now what's incredibly powerful is by creating a function, this really reads, what words am I searching for? I'm going to get file info, which gives me the word count. And then I'm going to make a CSV using word count as my, source. Whew. Cross your fingers, Daniel.
Here we go.
Here we go.
Let's light this candle.
And there we go.
Wow, very cool.
So there we go. But now, because I have these generalized functions, this is the last little bit. Are you ready?
Yeah, I think you're getting ready to blow my mind. I
Yeah.
have an idea that I think I know where you're going with this.
So I know that I have multiple files, and I'm actually going to put these in a folder, okay? So I'm going to create a new folder and just make it a text folder. So I'm going to move this here, and you could write a program that would go and search all of these things out. So I'm going to put them in a text folder so I know exactly where to look, and I don't have to say disregard the CSVs, disregard the weird little lock files. But I'm going to import OS, and I'm just going to temporarily comment this out and say, hey, print os.listdir of the text folder. Let's see what that does. Hey, that gives me all those texts.
Mm-hmm.
So now I'm going to uncomment these and say for text file in os.listdir of everything in the text directory, I want you to look for these words. This is the name of it, and we have to be careful. I know this is in the text directory, so I have to say text slash dot format of the text file. So I can say, hey, go find this in the text directory. And then here, I know that at the very end, I want to rename this with the original text, like Dracula analysis, Frankenstein analysis. So I have that and format, and I want everything up to the period of the original text file. So I'm going to, and I'll pull that in another variable so that's a little easier to fill. So new file name equals text file dot split, and I'm going to split on the period, and I'm just going to take the first part. So that's going to give me everything except the dot text part. And then I can say format with new file name. And now, for every file in that directory, I'm going to search for the words, grab the word count, and create a new analysis for every one of those.
This is going to rock.
This is going to rock. Well, I hope it rocks.
Yeah.
Because if it doesn't, I'm going to be a little sad. Syntax error. Oh. So what did I do here? Invalid syntax. Oh. I forgot to finish this line.
Requires a little extra.
Yeah. So go look for that. In the text directory, go find this text file, and I'm just building this string which represents a path. Get file info takes exactly 2 arguments, or 1 given. Oh, what? Search words. And I have three files analyzed in fractions of a second.
That was pretty incredible, actually. So, my mind is actually blown here. That was really cool. He had 3 files. We wanted to run the same function on each one of those files. And instead of going in and writing it over and over and over again for each 3 of those different files, created one thing, created all the necessary libraries and lists and things that he needed to search to get through it, put it all together, run it through one function, and it says, oh, okay, well now I'm moving into this file, I'm moving to that file, I'm moving to the next file, and do the same thing over and over and over again. And when I'm done, create these 3 lovely files using their own names as a basis for the new file name and set them in a folder for him so that he can check them out. Very, very cool, my friend. Is there any more after that? I don't know how you top that.
Well, I will say this pretty much encapsulates everything we've done up until this point, right? We've used lists, dictionaries. We didn't touch tuples. I could have made tuples to where get file info returns a new file name, or make CSV returns a new file name with the actual path and things like that. I could have done that, but in the sake of time, I decided not to. I used decisions, I used dictionaries, I used lists, I used for loops, iteration, I used my OS utilities, I used creation of functions, I used imports, my shebang. All of that stuff that I'm like, you just wait. We put it all together. And in 28 lines of code, and that includes line breaks between the functions, in 28 lines of code, I was able to sift through entire novels and do a word analysis. And this is just the surface. There is so much more that you can do, but I think it's time to let you simmer on that a little bit.
That's right. Let that seep into the bloodstream, permeate in the brain, think on these things, and start thinking of ways in which you can use what Justin has so graciously shown us in your everyday life and make some cool programs for yourself that work in your environment for your unique situation, do exactly what you need it to do instead of relying on other stuff. Justin, so cool. Thank you very much for showing us and taking everything that you've shown us thus far and culminating into one really awesome program. That's some cool stuff. That being said, it looks like we have finally ended our Python programming series. Hopefully you guys have enjoyed it. We had a lot of good times, and we hope you learned something as well. And we're going to go ahead and sign off for IT Pro TV. I've been your host, Daniel Lowry.
And can I say one quick thing before our final sign-off?
Go ahead.
There's a word in the community. You have now become a Pythonista.
Oh, a Pythonista.
I'm Justin Dennison. Have a great day.
Have a good one.